Hello guys, welcome to my YouTube channel. In this video we're gonna learn about how to find area generated by revolving a car around x-axis or y-axis. So let's start. So let's understand how this thing will happen. So area would be a equal to integration from a to b 2 pi y root over of 1 plus dy by dx whole square into dx. So all you have to do is to find the value of y, which is already given, and dy by dx. Okay, so let's take an example. Let y equal to 2 root x be a curve and the limits of x is from 1 to 2. Then suppose we revolve it around the x-axis. Then let's find out the area thus generated. So there is no need to draw curve, but if you want to see this curve, so it looks like something like this, 2 root x. And if you want to plot, then also you can use the table like this, where you will take random values of x and y. Let's suppose I'm taking x equal to 0, then the value of y would be, I have to put in the function which is 2 root x, so this value will be 2 into root 0, that is 0. Similarly for x equal to 1, it would be y equal to 2 root 1, so this value is 2. Again, if I am taking x equal to, suppose say I can take the negative numbers as it is root over. Okay, so I am taking a square number 4. So now the value of y would be 2 root x again. So that is 2 root 4, that is 4. So let's write down these values in order pair, x value and the first and y value in the second. Then second point is 1 comma 2 and the third one is 4 comma 4. So let's write it in the table, or simply just put in the graph. Then see, it is the 0 point origin, then 1 2 point will be somewhere here and the 4 4 point will be somewhere here. Now let's see the section. While writing the formula, it is from a equal to a to b 2 pi y root over of 1 plus dy by dx whole square into dx. Here I want to find the value of this dy by dx, as y we already know. Okay, so y is 2 root x and the limits are already known to us. A to b is 1 to 2 and the value of y, see, it is 2 root x, so I can substitute here. Then 1 plus dy by dx, this term I don't know, so we have to find out the derivative of y with respect to x. So you will do this before the setting of the solution, but let's do this here now. So as this y is equal to 2 root x, so we'll differentiate both sides with respect to x. Then it will be dy by dx which is derivative of 2 root x with respect to x. So this 2 is constant, so it will go outside of the limit, in derivative. Then this is 2 into d by dx of root x, and I can write this root x as x to the power half. Now what will be the formula then to find derivative? It is nxn minus 1, that is half x half minus 1. Okay, so here the n value is 1, so in place of 1 I have written half into x half minus 1. So now let's solve furthermore. This 2 will cancel out. Now this half minus 1 will be minus half. So take this to the denominator side, so it will be x to the power half, because we all know the formula as x to the power minus n equal to 1 by x to the power n. So now I got the dy by dx as 1 by root x. So use this dy by dx value in the formula to find the area. See, now say this 2 pi into 2, it is a constant term, so it will go outside of the integration. So I'm taking that 4 pi to the outside. Now integration values are from 1 to 2. Then value of y. Sorry, I have rewritten this 2 pi. Y value is 2 root x, right? So let's write it 2 root x. Now this root over 1 plus dy by dx, that is 1 by root x, we have already found out. So now let's solve furthermore. This value is 4 pi and integration is from a1 to 2, and this term it is already written in outside. So now let's solve this one. It is root x into 1 plus 1 by x. So let's rationalize this 1 plus 1 by x. So it will be x into 1 plus 1 by x into dx. So here this is 4 pi and this integration is from 1 to 2. This value is root x into the upper value is root over of x plus 1 by x. So now see, it is in the numerator and denominator part. I can separate the square root. So it would be root x plus 1 by root x. So now see, this root x and root x would be cancelled out. So all we are having with now root x plus 1. Instead of that I am writing 1 plus x. Now to solve such type of integration, we need to use the method of substitution, where inside the square root I will take the value t, and it is only applicable if it is in the form of a plus xb, where a and b are both constant. And the objective is here that we are changing this integration from x to t. So the limits and all these things will be changed. So let's write this 1 plus x is equal to t. Now we will differentiate both sides with respect to x or t as our base. So if suppose I am doing it with respect to x, then this value is d by dx of 1 plus x equal to dt by dx. Now using the linearity principle, it would be d by dx of 1 plus d by dx of x equal to dt by dx. Now see, in this linearity principle, if the value is in plus sign here, then it will change to the plus sign, and if there will be negative sign, then after linearity principle it will be negative sign. So now let's find out this value. So d by dx of 1, that is derivative of 1 with respect to x, which would be 0. Then derivative of x would be 1 and it is dt by dx. So let's solve, right? This 1 equal to dt by dx. Take this dx to the left hand side, it would be dx equal to dt. Now see, I have got the value of 1 plus x, which is t, and dx is changed to dt. Now all I have to change is this limit. It is from 1 to t. So let's change the limit to t. So I will use the formula from here. So when x is lower limit 1, so upper limit, t value would be 1 plus x, that is 1 plus 1 equal to 2. Similarly, when x is equal to the upper limit 2, then t would be 1 plus x, that is 1 plus 2 equal to 3. Now all the substitution let's put there. Then a equal to 4 pi integration. So integration limits are for the t. So t is from 2 to 3. So I'm writing 2 to 3. Then root over of 1 plus x, which is t, and dx is dt. Now see, I can write this root t as t to the power half, and the integration of t to the power half would be t to the power half plus 1 by half plus 1. So it is the same integration formula as that of x to the power n, which is integration from x to the power n dx, which is x to the power n plus 1 by n plus 1. So let's solve furthermore. This formula is same for t also. Whatever may be the variable, the formula remains the same. So now let's solve furthermore. It will be t to the power half plus 1, which is 3 by 2 divided by 3 by 2, and the limits are from 2 to 3. So how did I got this 3 by 2? Now we are just rationalizing the value half plus 1. So to rationalize, it would be 1 plus 2 into 1 by 2, that is 3 by 2. So now this one, it is 4 pi into 2 by 3, as this is a form of x by a by b. So now this value is 8 pi by 3 into t to the power 3 by 2 and 2 to 3. So now to use the limits, here that formula, how we got that 3 by 2 to 2 by 3. See, this formula is x by a by b equal to x into b by a. That's why we got from those steps. So now let's solve further. Here I will put the upper value and the lower value at t. So once we will take the upper limit, it is 3, so it would be 3 to the power 3 by 2, then minus, once we will take the lower limit at place of t, so it is 2 to the power 3 by 2. So in the exam hall you will have the scientific calculator, so you can find this value of 3 to the power 3 by 2 and 2 to the power 3 by 2. Also you will have the value of pi as 22 by 7 or 3.141 as you wish. And in such type of problems, you don't need to find whether the curve is smooth or not, because the question is already given to find area generated while it is revolved around some axis. Okay, so now let's see area of surface generated by revolving the curve about y-axis. So here the formula, as you remember in the first formula, it was whatever the formula is. From there you just interchange the x and y value, then we will get the area formula here. Okay, before that, just see this formula. It is let's define a little bit. Let x is equal to g of y is a function where x is a function of y, and we have to revolve this curve about y-axis. Then a is a equal to c to d. Before we have taken a to b in the last formula, and here we are using c to d to differentiate the limits of the x and y. Okay, so here it is 2 pi x into root over of 1 plus dx by dy. Okay, so if you can remember the last formula, then see just the x and y values are interchanged and the limiting values are from c to d. So here how you get confirm that this value would be dy or not. So just see, if there is x, then the value will be dy. So now let's take an example. Now let's take a line segment x equal to 1 minus y, and limits of y is from 0 to 1. Then it is revolved about y-axis. So let's find out this area, and so let's see how to solve this problem. First write the formula. A is from c to d 2 pi x root over of 1 plus dx by dy whole square into dy, and from here you know the value of x and you just don't know the value of dx by dy and the limit of integration, which is from c to d, right? So now say this x is equal to 1 minus y. So let's differentiate both sides with respect to y so as to find the dx by dy. So which is dx by dy equal to d by dy of 1 minus y, and we will apply the linearity principle in derivative. Linearity means simply just separate the terms, the derivative will go to 1 once, then to the y next, and the minus sign will be carried out further. So one derivative would be 0 and the y derivative is 1, so it is 0 minus 1, which is minus 1. So now let's put the values in the area formula. It would be limits are from 0 to 1. So a is equal to 0 to 1 as the limits are given. In place of x we write 1 minus y, and dy by dx dx by dy is minus 1, so into dy. Now see, all these terms are in y only. So now it is 2 pi is constant, it will go outside of the integration. Then it is 2 pi into 0 to 1, limits. Then 1 minus y, this value is 1 plus minus 1 square is 1 again. Now this value is 2 pi into 0 to 1, 1 minus y, root 2 into dy. So root 2 is again a constant, so it will go out of the limit. So it is 2 pi root 2, 0 to 1, 1 minus y dy. So here also, to integrate this one, we will use the linearity principle in integration, which is same. So it would be first the integration from 0 to 1 dy minus 0 to 1 y dy. So let's integrate these terms. It is 2 root 2 pi. See here are the terms 2 pi root 2 to root 2 pi, both are same thing. I just interchange these values. Then in the bracket, this value is integration of 1. You remember this value would be y, and limits are from 0 to 1 minus integration of y, which would be y square by 2. And the formula is same as integration of x to the power n, if you remember. Okay, so this value here I have to put the upper limit once minus lower limits once. So it would be 1 minus 0. First I have taken 1, then I have taken 0, then minus, see here this half is a constant, so it will go outside of the limit, and the limit is 0 to 1. So let's solve this in another step. It would be 2 root 2 pi, and 1 minus 0 is 1 minus half, and now again also the upper limit I will take once, so it would be 1 square minus 0 square. See, this value is 2 root 2 pi, and 1 minus half into 1 square minus 0 square, it is 1 minus 0. So this value is 2 root 2 pi into 1 minus half into 1 minus 0 is 1. So I'm not writing this again, and this value is 2 root 2 pi into 1 minus half is half. Now this 2 and 2 would cancel out, and the value would be root 2 pi. So it is the required answer. Hope you enjoyed the video. Thanks for watching. Don't forget to like, share and subscribe.